Hi, welcome back. In this section, we're going to start learning about muscle tone and then about some contracting muscles. So when we're talking muscle tone, we're talking about when you are sitting at rest. How many of those sarcomeres are just like lazing around doing absolutely nothing? And the answer is most, but not all. We always have some motor units that are active. And remember, a motor unit is the motor neuron plus all the muscle cells that it innervates. Okay. So even when you're just sitting here and your arms are just relaxed on your table, you're not doing any writing or anything, you're watching TV or whatever it is, having a chat, some of your muscles are contracted, and this is involuntary. We're not controlling it, and they go back and forth between being contracted and being relaxed. Now, when the muscle units contract, that is going to make your muscle firm up. But muscle tone does not make the muscle actually shorten in length. It just firms. And so this is what we call the resting tension for a skeletal muscle. And we have actually different types of sensory receptors that tell us what's going on in muscles and their tendons when we are at all the time. So the first type of proprioceptor is something called a muscle spindle. If you look at the drawings on your left, what you will notice is there is a grouping of myocytes, skeletal muscle cells, so maybe a half dozen or a dozen, and they are wrapped up in a little piece of a real or connective tissue. And that entire grouping, that is called the muscle spindle. And so these fibers within the muscle spindle, these are the ones where we are monitoring what's going on, but they're going to be doing exactly the same as the ones outside. And so when we look at the muscle spindle, what we notice is there's a sensory neuron that has dendrites wrapped around these muscle cells, and that's what's here in yellow. But in addition, we have motor axons that are going here, as well as to the rest of the motor unit, okay? So there aren't motor neurons just for the muscle spindle. The muscle spindle is part of the motor unit. And so what the muscle spindle is monitoring is stretch, and especially if the stretch happens quickly, okay? And so here's what happens. When you are relaxed, it's generating an action potential at a steady rate. But if you stretch that fiber, the rate of action potentials increases. And then if you go back to being relaxed, the action potentials slow down. So then what happens if you do the opposite of stretching? You do contracting. Well, then there aren't going to be any action potentials being generated because the muscle spindle's all squished down. It's very slack. There's no reason for firing action potentials. So that's how the muscle spindle works. Now, related to it, but totally different because it's not monitoring stretch and speed of stretch, is the Golgi tendon organ. And that middle word, tendon, is super important. That is telling you that this proprioceptor is not actually in the skeletal muscle itself, but it's in the tendon. And it's not monitoring stretch, it's monitoring tension in the tendon, which is going to happen at the opposite of stretch. It's going to happen when the muscle is contracting and pulling on the tendon. And so where exactly is this? It's in the part of the tendon right where it is coming off the skeletal muscle, okay? So it is right in this area. And if we were to blow this up, we have this picture in the middle, and what you would notice is this afferent neuron, the dendrites are all interspersed. So if you remember, a tendon is dense, regular connective tissue, and it is chock full of parallel collagen fibers. And so these afferent dendrites are tucked among these collagen fibers. So as any of them go under tension, the dendrite will be getting the message. Okay. So when the muscle contracts, basically that's going to increase the tension in the tendon, making those collagen fibers, which were nice and relaxed, now they're all squished tightly together. And so action potentials are going to go to the central nervous system. So if we look at the bottom right picture, what you will see, I think it's the red neuron, that's the sensory neuron. It's sending the message to the central nervous system, may just go in the spinal cord, may go higher up to the brain, come back down. But the motor neuron comes back not to the tendon, but to the muscle, to the skeletal muscle, causing the muscle to relax. Okay. So now what I'd like you to do is, when I'm done talking, stop a minute, read all the labels on this slide, and then talk yourself through both the muscle spindle, what activates it, how it works, the parts of it, as well as the Golgi tendon organ, because both of them are on this one drive. Okay. Great, thanks. Now, if you have any questions on that, be sure to ask me when we meet again next. So there's only a little bit more on this video, and that is to talk about two different categories of muscles contracting. The first is called isometric. So an isometric muscle contraction, this is like if you were sitting right where you are now, and I would say, tense the muscles in your anterior thigh, like contract your quads, okay? You're not doing anything to your legs, that your knees are still bent, your hips are still bent, but you can feel that tension going up. And this is what helps us with posture. It's what's keeping us upright, okay? When I'm slacking down like this, and I don't have the tension in my back muscle. It's also like if you were sitting here holding a weight and you weren't moving it, it would do that. It's what we do like when you're carrying your grocery bags. You have those weights. We're not doing elbow curls, usually when we're carrying our grocery bags. We're just carrying the weight in our hand. So we do have tension. If we look at this bottom right, the green line is showing the length of the muscle fiber, and the length of the muscle fiber is not shortening. We are not causing any flexion or extension or any other type of movements. But the blue line is showing that we are developing tension, and we're just holding that there, and then the muscle relaxes. So in an isometric muscle contraction, the muscle does not change length, but tension develops. So you know which proprioceptors are being active. And this is what happens, for instance, when you are doing yoga as a type of exercise. There's a lot of isometric muscle contractions going on. And yes, you really can work up a sweat and get a good exercise in there. Now, the other type is the type that we use when we're thinking of, oh, I'm exercising, and that is isotonic muscle contraction, where the muscle is shortening and movement is occurring. And if you are a kinesiology major or taking physio later on, you'll learn that there's two different types of isotonic muscle contraction, but that's not for this course. So in this course, we just know an isotonic muscle contraction not only has tension developed, but the muscle itself is shorter than the resting tone. All right. So lastly, why do we warm up and why do we cool down when we're exercising? Well, those enzymes which your muscle needs in order to generate the ATP for work, they work a lot better when the muscle is warm, so that the muscle contractions, the twitches, will be much more effective and stronger when the muscle is warm. And so this is why you have to do a warm up. And then you can do all your exercising. At the end, when you're doing a cool down, and you can always see your Olympic athletes, they may have just run a marathon, but now they're running another lap. They're doing a cool down period. And the reason for that is the mass amount of oxygen need for the muscles is decreased, but we want to keep up the blood flow into the muscle so that we have more oxygen going in to wash out any waste and to get rid of any possible oxygen debt. So that's something you would definitely learn a lot more about if you're a Kin PT major when you learn about exercise physiology. And the last thing I have shown over there are a bunch of stretching exercises, and that is because People often do a lot of their stretching before they do their warm up, which is just so counterintuitive because you need things warmed up and have increased blood flow. And if you do your stretching exercises at the end of your cardio exercises, then what you're going to be doing is increasing your range of motion. If you try to do them, especially before your warm up, you are going to be much more likely to end up having some tears, which would not be a good thing. And with that, we are done. I want to thank you so much for all your hard work, and I will see you again soon.